Here's our experiment on recrystallization. And as a reminder, this is going to be a good technique for purifying solid compounds. And it takes advantage of the difference in solubility of different compounds in a particular solvent. The nice thing about it is it's really amenable to scaling up. It's very commonly used in industry because to collect your product, all you do is a filtration. So since you're dissolving your sample in a minimum amount of solvent, it also reduces the amount of waste you make. If you compare it to something like column chromatography that we'll talk about a little bit later, where you're constantly running solvent through, so you produce a lot more waste. So if you have the choice, recrystallization is going to be a very great technique for purifying compounds, solid compounds. So a few parts of the experiment. The first thing we're going to do is experiment 2, and that is recrystallization of phthalic acid, a known compound, so you have that there, and we're going to do it on approximately a 60 milligram scale. So something to remember is that it doesn't have to be exactly 60 milligrams, just approximately, and make sure you record the exact amount that you use so we can calculate a % recovery at the end. So here's the basic setup. The very first thing I recommend doing is setting up your hot plate. You can go ahead and plug that up in the fume hood and set up your beaker. So this beaker is going to be somewhere between 50 and 100 milliliters. And a good idea too is to go ahead and clamp it, so you have the bars in the back of the hood. You can go ahead and clamp your beaker down. That way you don't have to worry about anything tipping over. I would start with the heat setting of 4, and then you can just adjust it accordingly. Make sure you also add a boiling stone. So before you do anything else in the experiment, go ahead and get your hot water bath set up, and then you can go back and you can weigh out your sample, and actually you can also start experiment 3 that we'll talk about in a moment. So the next thing is you'll get a reaction tube from your microscale kit, and you're going to weigh out approximately 60 milligrams of your sample. Since we're working with such small amounts, I recommend putting your reaction tube into something like a small beaker and zeroing it out and weighing your sample directly into the reaction tube instead of using weigh paper. That way you don't have to worry about losing material when you're transferring. So at that point, and make sure when you set up your hot water bath, you also add a boiling stone. The next thing we want to do is go ahead and start the recrystallization, and we are doing this in water. So recrystallizing phthalic acid in water, so make sure this is also deionized water. And what you'll do is, before you put your reaction tube into the water, we need to make sure we add some hot solvent into it first. So you'll add a very small amount of hot water. You can take it straight from your beaker and add it into the reaction tube. Once you have liquid in there, then you can set it or place it into the boiling water. When I say a small amount, you don't want to add a whole pipette full. I would add somewhere between a third and no more than half of a pipette full. And then you'll just keep adding very small amounts of hot water until your compound is fully dissolved. Once your compound is fully dissolved, don't add any more solvent, no more water. So the most common mistake in this experiment is adding in too much solvent. So once you've dissolved your compound, then no more solvent. What you'll do is you'll take it out of the hot water bath and you'll clamp it, and we want to let it cool slowly, so that way hopefully it crystallizes out without also precipitating any impurities. So just leave it there. What you can do during this time is one of two things. So we are going to do everything individually except for experiment 3. So what you can do is you can go ahead and set up experiment 3 at this point, or you can set up your vacuum filtration apparatus. But you want to make sure you cool it all the way to room temperature, so you can take a thermometer to check it. Once it's completely cooled to room temperature, we want to make sure we get as much compound back as possible, so then you will place your reaction tube in an ice water bath. So 5 to 10 minutes is going to be the minimum, But remember, you can always leave it in there longer. So this is another point where you can either, if you haven't already set up your vacuum filtration apparatus, you can do that. You can start weighing out your compound in a new reaction tube for your unknown. There are lots of things you can do to work efficiently during this time because, again, you can always leave it in there longer, just minimum 5 to 10 minutes. Okay, so after you've let your reaction tube sit in the ice water bath for at least 5 to 10 minutes, now we want to collect our product using vacuum filtration. And something else I would make sure you do is cool some deionized water, because you will need to rinse with a little bit of that, and also cool a little bit of ethanol. So we'll do a final quick rinse with ethanol. You can pour your sample onto the top, so make sure you have this set up first. Let's talk about that. You have your small Hirsch funnel that's already connected to a vacuum flask. You have tubing that goes to the trap flask, and we talked about this way, if some liquid gets sucked up into here, it doesn't go directly to the vacuum. So you have that connected on the top, and then that side arm goes to the actual vacuum. And make sure you also have this clamped down so it's not tipping over. You can actually clamp both of these to the same ring stand. I have it shown separately here, but you can clamp them both to the same ring stand. And make sure you put a piece of filter paper in there and wet it before you add anything here. That way we don't clog up the pores, and then it will slow down the filtration. So you can pour your sample on top. You can use a spatula to get as much compound out as possible. And then if you still have some crystals left in the reaction tube, what you can do is use a small amount of cold water, very, very small amount, and it has to be cold. That way you don't redissolve your sample, to rinse and add it to the Hirsch funnel. The very last thing we're going to do, and it's because water is really hard to get rid of, we're going to wash with a tiny amount of cold ethanol. So a half a pipette of cold ethanol is fine for the amount of solid you're going to have. And once you do that, and just make sure it's as dry as possible, you can go ahead and turn the vacuum off and disconnect this, and you can collect this and weigh it. Since we're washing with ethanol to go ahead and fully dry it, you can weigh it on the same day. Since you're doing a second recrystallization, which means you'll have to use this vacuum setup again, we want to make sure we clean it properly. The proper way to do it after you've already collected your solid is to turn on the vacuum again and take one of the rinse bottles that has acetone in it and go ahead and spray some acetone through, and that just make sure anything that's on those pores gets cleaned up before you do your second filtration. So the next thing we want to do is we want to calculate a percent recovery. And we're not going to worry about a melting point in this case, but the percent recovery is going to be equal to the grams that you collected at the end, and you're going to divide that by the grams that you started with, so somewhere around 60 milligrams, and you're going to multiply by 100%. So you want to see, of the amount you put in, how much you actually got back. For the decolorizing step, this is the only part you're going to work on in pairs. And again, what you can do is you can set this up during one of those break points. So maybe you're waiting to cool to room temperature, or you have something in the ice bath, and you'll just set it up, and then at the very end of the experiment you'll observe. So you want to take another reaction tube, put 1 milliliter of the methylene blue dye solution, and then you want to add the norit pellets, so 10 to 12, and you can swirl it around a little bit and just clamp it in the back of your hood, and you want to observe the color change. What you can also do is towards the end, you can place it briefly in the hot water bath and then see if the color changes anymore. If you still have some color there, you can always add a few more norit pellets. You just want to make sure you do it when it's not inside the actual hot water bath. You want to make sure that's pulled out if you have it in the hot water bath, and just observe the color change. For the last part of the experiment, this is where you are recrystallizing your unknown sample. So for this, we don't know what solvent is going to work best, so you need to do a solvent test first. I want you to start with water, and then if water doesn't work, you can try methanol. So a good solvent, the way we're going to test it is in just a regular test tube. use just a very small amount. So just a pinch of your unknown, just like you're getting a sample for your melting point, very small pinch. All right, so you want it to be insoluble at room temperature, right? And again, you're only adding a very small amount of solvent as well, just a small amount from the pipette, right? The next thing you want to do is place it in the hot water bath and just make sure it's soluble when heated. And the last thing, and you don't have to wait for it to slowly cool to room temperature, just place it in an ice water bath, and it needs to be insoluble in ice water. So make sure that you're going to get solid back, right? Once you've determined your solvent, so start with water. If it doesn't work again, go through this process with methanol. Once you've done that, then you can use the same procedure that you did with the phthalic acid to go ahead and recrystallize around 100 milligrams. So make sure you record exactly how much you use. Some things to keep in mind: if you need to use methanol as a solvent, you need to heat some, so that way you're able to add hot solvent for your recrystallization. And you also need to cool some for when you collect it on the Hirsch funnel. When you need to rinse, you need to rinse with the same solvent. At the end of the experiment, make sure you rinse all glassware with acetone. So you'll rinse it with acetone into the waste container, and then you can clean it like you normally would. So just to make sure any compounds that are left over get put into the waste container. You don't have to worry about drying all your glassware. If you do a final rinse with acetone, it evaporates very quickly and all your glassware will be dry. What we're going to do is, for this one, since we're not washing with ethanol, so we're not doing that final rinse with ethanol, what we'll do is you can collect it onto a watch glass instead. Make sure you pre-weigh your watch glass, and then we will wait until the next lab period to weigh it again, right? After you weighed your sample, so that way you can also calculate a % recovery, the last thing you'll do is you will transfer your sample into a little bag that I'll show you, and you want to label it. So you'll label it with the experiment number, your unknown number, and if it's a known, in this case it's an unknown, but if it were a known compound, you'd write down what it is and also write the date. So that is about it for this experiment. I recommend just thinking about the experiment as a whole and how you can work through efficiently. So what places you have downtime where you can maybe start on something else, that's a good idea. So that way you come in organized.